Hey everyone, welcome back to Let's Do Mathematics. Today we are solving a really interesting problem from JEE Advanced 2019. It's about cube roots of unity and finding a minimum value of using some neat algebraic identities. Let's start. So we have given omega is a cube root of unity and we have to find out the minimum value of the set mod of a plus b omega plus c omega square, where a, b, c are distinct integers. So first of all, we know that omega is cube root of unity, means omega cube is equals to 1, and omega is equals to e raised to power iota 2 pi over 3, and omega square is equals to e raised to power iota 4 pi over 3. Also note that omega conjugate of omega is equals to omega square, and conjugate of omega square is equals to omega. Now using these concepts also, we know that mod of z square is equals to z times z bar, that is conjugate of, that is product of complex number and its conjugate, so gives the modulus square. Now we have given quantity is mod of a plus b omega plus c omega square time raised to power 2. So we can write this as a plus b omega plus c omega square times a plus b omega plus c omega square under conjugate. Now we can write this as, this is equal to, we can write a plus b omega plus c omega square times a conjugate plus b omega conjugate plus c omega square conjugate by property of conjugates. So we can write this as a plus b omega plus c omega square. We know that conjugate of real number is a real number itself, so this is a plus b omega bar plus c omega square bar. Now we can write this as a plus b omega c omega square, and this is equals to a plus, this is the conjugate of omega is omega square, and the conjugate of omega square is omega. Now after multiplying, we have, if we multiply these two quantities, we have a plus b omega square plus c omega plus b omega times a plus b omega square plus c omega plus c omega square times a plus b omega square plus c omega. Now we can write this as a square plus ab omega square plus ac omega plus ab omega plus b square omega cube plus bc omega square plus ac omega square plus bc omega raised to power 4 plus c square omega cube. Now we know that omega cube is equals to 1, so omega raised to power 4 is equals to omega, and so using this we can write this as a square, and this is b square times 1, so this is b square, and now this is c square. So we have a square b square plus c square. Now we have ab plus bc plus ca times omega square, so this is times omega square plus, this is ab plus bc plus ca times omega. Now we know that omega raised to power 4 is equals to omega, so this is bc omega. So we can, after taking terms having omega square and omega at one place, we get like this. Now a square plus b square plus c square, and now if we take ab plus bc plus ca as a common, we have omega plus omega square. Also we know that the property of cube root of unity is 1 plus omega square is equals to 0. So omega plus omega square is equals to minus 1. So we have a square plus b square plus c square, and this is, if we multiply this minus 1, we have minus ab minus bc minus ca. Now we can write this quantity as half 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca. So if we can write also this as a square plus b square minus 2ab plus b square plus c square minus 2bc, and now this can be written as c square plus a square minus 2ac. Also we can write this as half a minus b whole square plus b minus c whole square plus c minus a whole square. As a, b, c are three distinct integers, the minimum difference occur when the numbers are consecutive. So if a is equals to k, then b must be k plus 1, and if we take c is equals to k plus 2, without loss of generality we can take integers like this. So b minus a is equals to 1, b minus c is equals to minus 1, and c minus a is equals to 2. So using this, the minimum value is half. Putting these values in this bracket, we have 1 square, this is minus 1 square plus 2 square, so this is equal to 1 half plus, this is 1 half times 6, so this is 6, and that's equals to 3. So this is the required minimum value of the given problem. This problem beautifully combines concepts of cube roots of unity, conjugates modulus squared and algebraic identities. A perfect example of how JEE tests both your concepts and your ability to spot simplifications. If you found this helpful, hit like, subscribe for more JEE problem breakdowns, and share with your friends preparing for advanced. Until next time, keep practicing and keep enjoying mathematics. Thank you.